we are the UC Irvine Solar Airplane.
On sunny days only.
I am Sang-Yu Ung, the project manager for the 2019 to 2020 academic school year, and our project advisor is Yoon Wang.
I am the fuselage team lead, Andre Nico Chavarne.
I'm the avionics lead, Christopher Tejeda Behar.
I'm the tail sub-team lead, Forster Sherrick.
I'm the wing sub-team lead, Samuel Beltran.
Our project is currently composed of 24 active members, but we do expect that number to fluctuate as the year progresses. This is currently our 8th year standing and our 2nd year attempting to build a plane completely from scratch. From previous years, we have used model kits such as the image on the right, and for last year, they attempted to make a plane completely from scratch. But for this year, we will be improving the design and extending the flight time by 10 minutes.
So our primary objective is to design and manufacture a UAV that uses solar panels to increase flight time of an aircraft by 15%. The airplane is designed to be used for disaster relief, so it should be able to hold data recording instruments up to 2 pounds, which can include a camera and other sensors to analyze the situation.
This is the list of our requirements and specifications. Our UAV has to be less than 15 pounds. It has to have a maximum dimensions of 24 feet squared. Our technical payload has to be less than 3 pounds. Our minimum flight time is 10 minutes. Our battery should give us enough power to extend our flight time, or solar panels should give us enough power to extend our flight times by 15%. We must incorporate a camera. We have to fly at an altitude between 300 and 400 feet above sea level. We must have at least 2 subsystems to compensate, 2 flight control systems to compensate for any operator or environmental conditions, and we should at least have 1 component made out of carbon fiber.
As you can see, this is the timeline, and we are successfully following the engineering design process.
Our team is broken down into 4 different components. We have the leads for each sub-team, which is the avionics, the fuselage, the wings, and the tail. In each sub-team, there are minimum 4 members and maximum 6 members.
So for avionics, after much research, we decided to divide our sub-team into essentially 4 subsystems. We have the microcontroller and the flight controller, the solar panels, the camera, and the motor. For the flight controller and the microcontroller, we decided to use Arduino, because with the Arduino we could mix both of them into one, and therefore we reduce weight and we reduced our cost. For the solar panels, we decided to use a thin film flexible solar panels. For our camera, we'll be using an ArduCam mini camera shield. And then for the motor itself, because our maximum weight is 15 pounds, we decided to use the Power 60 brushless 470 kV motor, and then the ESC that's recommended for that by the manufacturer is the 80 amp brushless. This is our wiring diagram for our electric components, and this is how the MPPT is connected to the solar charger right here.
For the fuselage, after extensive research, we decided to work with semi-monocoque style, and we're going to do a monocoated skin. The measurements will be 0.5 or half foot width, half a foot height, and 2.51 feet of length. And we're going to use balsa wood and carbon fiber rods. Mostly the carbon fiber is going to be to connect to the tails. And then once we got the wings size and weight, as well as the tail position and the tail design, we were able to get the center of gravity and that was when we were able to develop the landing gear with the center of gravity, because that's where we're going to place it. And it was made based on a previous iteration, and it was made so it is able to absorb as much shock as possible. And We were also working on the takeoff mechanism. We're going to be using a bungee launch. Bungee launch is cheaper and much safer than other methods proposed.
The design process of the wings started off with using the data from last year's, such as a case study of aspect ratios, and then the recorded data from cruise speed and stall velocity. Using this data, we decided on a high-mounted wing design. We needed to be removable in order to be transportable, and we decided to be rectangular since that was a recommended option that they followed through with last year. Our measurements will be 8 feet with 8 feet span with 0.8 feet or 9.6 inches wide, so that it can fit in with the 10 aspect ratio. And through this characteristics, we decided on 4 final airfoils, and from there we did various simulations, and we came out with the MH114 airfoil as our final airfoil for the wing. Some of the materials that is going to be used is going to be balsa wood and carbon fiber in order so that it will not be so restricted by its weight. And we had to design a fuselage box in order to connect the wings to the fuselage so that it will not break through the middle.
So for the tail, we decided to go with the classic T-shaped design. This model is commonly used on model airplanes, and it provides good stability. For the material, we are using balsa wood because it is easy to manufacture, light, and cheap. For the elevator and rudder design, we want to use a push rod mechanism with a rod inside of the fuselage that connects to the servo. And we want to use a hinge connection to the tail. To move the control surfaces, we want to implement a 4-bar mechanism. The tail's measurement properties include a width of 51 inches, a height of 18.6 inches, and a thickness of around 1 inch. For the connection to the fuselage, we want to use an adhesive with multiple screws drilled into the carbon fiber rod that is connected to the fuselage. The block you see on the CAD model is so that we can implement the attachment without damaging the stabilizers.
Our goals for this last quarter was to create a first prototype and then begin the simulations for the whole airplane, for the UAV. The current work that we have to do for this upcoming quarter is to further the simulations and further optimize the airplane. What we hope to do in the future quarters is to assemble and final optimizations. And over here we have our first prototype of the UAV.
From the engineering design process, we will be entering the second phase of our project. We will be starting the manufacturing by ordering all the parts needed for each sub-teams, and we will be assembling the whole entire plane and using monocoats to cover the wings and the fuselage. We will also be incorporating the avionics component into the fuselage. Thank you very much for listening to our presentation today.